Alright, let's look at the homework 4.7, problem number 5. A right circular cylinder is inscribed in a cone with height h and the base radius r. Find the largest possible volume of such a cylinder. Alright, so let's do that. Alright, so I already drew the cone with height h and with radius r. Alright, so the inscribed cylinder should look somewhat like this. So it's going to look something like that. Alright, so since we don't know the radius of the cylinder yet, let's call that guy x. Say, so the radius here, right, so that would be x. Alright. Then height of the cylinder is simply, let's see, we have to find the equation for this one. So y-intercept is h and slope is negative r over negative h over r. So the equation of this line here is y equals, right, slope is, right, run would be r. Right, rise would be, actually it comes down h, so it's negative h x, and the y-intercept is h, so it's going to be plus h. Right, so I'm having equation of the form mx plus b. Right, then since x value is x, so this guy right here, so height can be written as this. So this height right here is negative h over r x plus h. Alright, so if you want to find the volume of this circular cylinder, that will be v is equal to, alright, pi r squared h. So it's a pi r, radius is x, so x squared times h is just a negative h over r x plus h. Alright, then let's see, I'm gonna actually distribute this x squared in here and also in here to get this. This is going to be pi. Then you have a negative h over r x cubed plus h x squared. Alright, then actually h is in common, so I'll pull this this guy out. So here's a h here and h here. I'm gonna pull this guy out here so that we have just h pi. Then you have negative 1 over r x cubed plus x squared. Alright, so this is the volume function, and we can take the derivative so that we can find the critical number. So derivative is going to be, alright, h is just a number and the pi is just a number, and it's going to be negative 3 over r x squared plus 2x. Alright, so that's the derivative. So x is in common, so we can write h pi x. Then you have a negative 3 over r x plus 2. Alright, set that equal to 0, and we can find the critical numbers. So x equals 0 is obviously a critical number, but it's not exactly what we're looking for. But here, x equals, let's say it's going to be a 2/3 r. So 2r over 3 would be the other critical number. Right? So you can see that if you plug in 0, it's going to be the volume is going to be 0 anyway. So we won't want that. So we're going to have a maximum at x equals 2r over 3. So the volume that we're looking for would be, right, so the volume V is equal to, at the 2R over 3 would be, alright, so we have to simplify this. Let's see, we'll probably plug it into, where should I do it? Maybe do it right here, alright? So it's a pi, let's see, H pi, maybe I'll do it there, alright? So negative 1 over R, right, x cubed. So that would be 3 cubed, so 27. And then you have 2r cubed, so it's going to be 8r squared, cubed. Alright, so we can cancel r, and this is going to be squared now. Alright, and then you have a plus. Alright, x squared, so x is 2r, so it's squared 4r squared over 9. Alright, so if you simplify that and taking a common denominator, so we have, alright, so 27, common denominator, 27, alright, so it's a minus 8r squared, right? Then plus, so multiply by 3, so 12r squared, right? So it seems like, let's see, negative 8 plus 12, so it's going to be 4r squared. So you have 4 pi r squared h over 27, right? So that's that. Right, so that's the maximum volume. So let's plug it in. Right, so we got the 4 pi r squared and h over 27. Right, so let's submit for testing. Alright, I came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.